Across the unfathomable darkness of intergalactic space, a drama of titanic proportions appears to unfold. We bear witness to what seems to be an act of cosmic violence, a celestial collision captured in a single breathtaking moment. Here, suspended against the velvet black, is the spiral galaxy designated NGC 105. It is a maelstrom of starlight, a swirling vortex of perhaps 200 billion suns, its luminous arms wrapped in a delicate yet chaotic embrace. But it is not alone. Seemingly embedded within its very structure, caught in the gravitational snare of its larger companion, is a smaller, more compact galaxy. This lesser system appears to be plunging directly through the primary galaxy's disk, a cosmic bullseye scored on a galactic scale. The visual evidence for this cataclysm is overwhelming, painting a picture of gravitational distortion and impending merger. The elegant spiral arms of the principal galaxy are twisted, warped from their perfect logarithmic curve. Streams of stellar material seem to be pulled and stretched, forming faint ethereal bridges and tails that whisper of a powerful gravitational disturbance. You can almost hear the silent scream of a trillion celestial bodies caught in a gravitational tide, a slow-motion catastrophe playing out over millions of years. This is a narrative we understand, a story written in the language of physics that we have seen acted out elsewhere in the cosmos. Galactic mergers are a fundamental engine of cosmic evolution. They are how galaxies grow, how they change shape, and how they ignite furious bursts of new star formation. This apparent collision in the constellation of Pisces looks like a textbook example, a snapshot of creation and destruction intertwined. It is a vision of two island universes, once solitary travelers in the void, now locked in a final transformative dance. But what if this entire spectacle, this grand and violent narrative, is nothing more than a trick of the light? What if the titanic struggle we think we are observing is in fact a profound and beautiful deception? Suppose this dramatic scene is merely an illusion, a chance alignment of cosmic actors on a stage, 100 quadrillion kilometers deep. The story of NGC 105 is not the story of a collision. It is the story of a cosmic mirage and of the ingenious methods humanity has developed to see through the universe's most convincing lies. To appreciate the depth of this deception, we must first understand why the idea of a galactic collision is so compelling and so plausible. Our comprehension of these cosmic encounters is a relatively recent marvel in the long history of human thought. For millennia, the heavens were a realm of serene perfection, a tapestry of fixed points of light. The faint, fuzzy patches of light that early astronomers noted were mysteries catalogued as nebulae, Latin for clouds, without any true understanding of their nature. Pioneers like the French comet hunter Charles Messier in the 18th century listed these smudges to avoid confusing them with comets. His catalogue entry for the Andromeda Nebula Messier 31 was simply another curiosity among many. A century later, the brilliant observer William Herschel, with his sister Caroline, peered deeper into the void with larger telescopes. They discovered thousands of these celestial clouds, noting the spiral structures within some of them, yet their true identity remained shrouded in mystery. Were they nascent solar systems swirling gas clouds within our own Milky Way, or were they something far grander and far more distant? This question ignited one of the most significant intellectual battles of the 20th century, the Great Debate of 1920. In Washington, D.C., two brilliant astronomers, Harlow Shapley and Heber Curtis, stood before their peers and argued passionately over the scale of the universe. Shapley contended that the Milky Way was the entirety of the cosmos and that these spiral nebulae were mere local phenomena. Curtis conversely championed the radical notion of island universes, proposing that these were galaxies in their own right, colossal collections of stars. just like our own, separated from us by unimaginable gulfs of empty space. The debate was fierce, the evidence on both sides compelling but ultimately inconclusive. The universe hung in the balance, its size and scope unknown. The stalemate was shattered less than 5 years later by the meticulous work of Edwin Hubble. Using the monumental 100-inch Hooker telescope at Mount Wilson Observatory in California, Hubble resolved individual stars within the Andromeda Nebula. Crucially, he identified a specific type of pulsating star known as a Cepheid variable. These stars are cosmic lighthouses. Their intrinsic brightness is directly linked to the rhythm of their pulsations. By measuring how fast a Cepheid variable blinked, Hubble could calculate how bright it truly was. Comparing that absolute luminosity to how dim it appeared from Earth allowed him to calculate its distance with unprecedented accuracy. The result was staggering. Andromeda was not a nearby cloud. It was millions of light years away, a breathtakingly distant and enormous system of stars. Curtis had been right. The island universes were real. The cosmos was exponentially vaster than humanity had ever dared to imagine. With this newfound understanding of galaxies as distinct entities, the possibility of their interaction became a subject of intense study. Astronomers realized that the universe was not a static diorama. It was a dynamic, evolving environment where gravity acting over immense timescales would inevitably draw these colossal structures together. A galactic collision, however, is not like two solid objects smashing into one another. Imagine two swarms of bees, each 100 miles wide, flying through each other. The individual bees have an infinitesimal chance of actually making contact. Space is by its very nature mostly empty. Galaxies are much the same. The stars within them are like tiny isolated specks separated by immense voids. If two galaxies like the Milky Way were to merge, the probability of any two individual stars physically colliding would be virtually zero. Instead, a galactic merger is a story of gravity. It is a gravitational ballet, not a demolition derby. As the two galaxies approach, their immense gravitational fields begin to interact, raising stellar tides. Long, graceful arcs of stars and gas, known as tidal tails, are drawn out from the galactic disks like saltwater taffy being pulled and stretched. The internal structures of the galaxies are violently disrupted, their beautiful spiral arms torn asunder, and their stars thrown into new chaotic orbits. While the stars themselves glide past one another, the vast, diffuse clouds of interstellar gas and dust are not so fortunate. These enormous clouds, the birthplaces of new stars, do collide directly. They slam into each other with tremendous force, creating powerful shockwaves that compress the gas to incredible densities. This compression triggers a firestorm of star formation, a phenomenon known as a starburst. Across the merging galaxies, millions of new, brilliant blue stars are born in a short, spectacular frenzy, illuminating the mangled structures with their intense, youthful light. We have seen this glorious process elsewhere. The antennae galaxies, for instance, are a pair of interacting spirals caught in the throes of a merger. Hubble's portraits of them reveal a chaotic mess of tangled gas, glowing pink nebulae, and brilliant blue star clusters, all woven together by the relentless pull of gravity. The mice galaxies showcase the early stages, two systems trailing impossibly long tidal tails of stars behind them as they make their first close pass. Even our own galaxy, the Milky Way, is on a collision course. In about 4.5 billion years, we are destined to merge with our neighbor, the Andromeda Galaxy. Our distant descendants may look up at a night sky ablaze with the light of 1 trillion new stars, a sky utterly transformed by this cosmic union. So when we look at the image of NGC 105, our minds, now trained by these examples, see all the telltale signs. we see the distorted arms of the larger galaxy. We perceive the smaller companion seemingly captured in the act of plunging through the disk. The narrative of a collision seems not only plausible but practically inevitable. It is a story that fits the visual evidence perfectly, and yet this compelling narrative is completely and utterly wrong. The key to unmasking this grand cosmic illusion lies not in what we can see, but in an invisible property of light itself. It is a phenomenon known as redshift, and it is the universe's own speedometer. To comprehend redshift, we must first think about sound. Imagine standing by the side of a road as an ambulance, its siren wailing speeds past. As the ambulance approaches, the sound waves are compressed, reaching your ear more frequently, and you perceive a higher-pitched siren. The moment it passes and begins to move away, the sound waves are stretched out, reaching your ear less frequently, and the pitch of the siren drops dramatically. This is the Doppler effect, and light behaves in a remarkably similar way. Light travels through space as a wave. Visible light with shorter wavelengths appears blue or violet, while light with longer wavelengths appears red or orange. If an object in space like a galaxy is moving towards us, the light waves it emits are compressed. They are shifted towards the shorter wavelength blue end of the spectrum. This is a blue shift. Conversely, if a galaxy is speeding away from us, the light waves it emits are stretched. They are elongated, shifted towards the longer wavelength red end of the spectrum. This is a redshift. The greater the speed of recession, the more the light is stretched, and the greater the redshift. This principle is the bedrock of modern cosmology, the primary tool we have for measuring the motion and distance of objects in the deep universe. The story of its discovery belongs to a quiet, unassuming astronomer named Vesto Slipher, working at the Lowell Observatory in Arizona in the early 1910 seconds. While Hubble would later get much of the credit, it was Slipher who did the painstaking foundational work. Using a device called a spectrograph, which acts like a prism to split light into its rainbow of constituent colors, Slipher analyzed the light from those mysterious spiral nebulae. He discovered that embedded within this spectrum of colors were dark lines, specific frequencies of light absorbed by elements in the galaxy's stars. These absorption lines acted like cosmic barcodes, unique fingerprints for elements like hydrogen and calcium. Slipher found something astounding. In nearly every spiral nebula, he observed these familiar barcode lines were not where they were supposed to be. They were systematically shifted towards the red end of the spectrum. This could only mean one thing. These galaxies were moving away from us, and at truly incredible velocities, some in excess of 1,000 kilometers per second. It was this foundational discovery that Edwin Hubble later synthesized with his distance measurements to formulate Hubble's law: the farther away a galaxy is, the faster it is receding from us. This was the first evidence that the universe itself is expanding, and it is this exact technique, this analysis of cosmic barcodes, that shatters the illusion of NGC 105. When astronomers turned their spectrographs towards this dramatic scene, they did not just look at the system as a whole. They carefully isolated the light from the large main spiral galaxy, NGC 105 itself, and then they separately isolated the faint light from the smaller, seemingly embedded companion galaxy. They analyzed the two spectra, the two cosmic barcodes, and what they found was definitive. The light from the grand spiral galaxy NGC 105 exhibited a redshift corresponding to a recession velocity of about 4900 kilometers per second. This places it at a distance of roughly 215 million light-years from Earth. This is a vast but not unusual distance for a galaxy of its type. But when they examined the light from the smaller companion, the story changed completely. Its spectrum was dramatically more redshifted. Its barcode was shifted so far to the red that it indicated a staggering recession velocity of over 14300 kilometers per second. This is nearly 3 times faster than the primary galaxy. According to the law of cosmic expansion, this means the smaller galaxy is not a close companion at all. It is in fact an unrelated background object located approximately 630 million light-years from Earth. The smaller galaxy lies more than 400 million light-years behind NGC 105. The colossal chasm of empty space that separates them is more than 4,000 times the diameter of our own Milky Way galaxy. There is no collision, there is no interaction, there is no gravitational dance. The two galaxies are complete strangers, separated by an abyss of time and space that is almost impossible for the human mind to fully grasp. What we are witnessing is nothing more than a trick of perspective, a chance alignment along our specific line of sight from Earth. It is a cosmic photobomb of the highest order. This revelation forces us to confront a fundamental truth about our perception of the universe. The night sky as we see it is an illusion of flatness. Our eyes and brains have evolved to navigate a three-dimensional world on Earth, but when we look up, we lose all sense of depth. The stars appear as points of light sprinkled onto a two-dimensional celestial sphere. This is the very basis for the most ancient form of cosmic illusion, the constellations. Consider the familiar pattern of Orion the Hunter. To our eyes, the stars Betelgeuse and Rigel, which form his shoulder and foot, appear as part of a cohesive group. They seem to be neighbors on the celestial sphere, but in reality they are utterly disconnected. Rigel is a brilliant blue-white supergiant located about 860 light-years away from us. Betelgeuse is a bloated red supergiant, much closer at a distance of about 550 light-years. The stars of Orion's belt, Alnitak, Alnilam, and Mintaka, lie at distances of 126020000 and 1200 light-years respectively. If you could fly a starship through the constellation, you would find that the familiar pattern dissolves into a meaningless random scattering of stars at vastly different depths. The mighty Hunter is a projection, a pattern our minds create from unrelated points of light. The universe is replete with these perspective tricks. Sometimes gravity itself becomes the master illusionist. Albert Einstein's theory of general relativity tells us that massive objects warp the fabric of spacetime around them, like a heavy bowling ball placed on a stretched rubber sheet. Light, which normally travels in a straight line, must follow these curves in spacetime. On rare occasions, a very massive galaxy or cluster of galaxies lies directly between us and an even more distant object like a quasar. The immense gravity of the foreground galaxy acts as a cosmic lens, bending and magnifying the light from the background quasar. This phenomenon, known as gravitational lensing, can create bizarre and beautiful illusions. Sometimes the distant quasar appears as a shimmering ring of light known as an Einstein ring. In other cases, like the famous Einstein's cross, the light is split into 4 distinct, separate images of the same single quasar, arranged in a cross-like pattern around the central lensing galaxy. It is another case where our eyes see multiple objects, but the universe tells us there is only one. Understanding these illusions requires us to appreciate the true three-dimensional structure of the cosmos, a structure we can only map out through painstaking measurement. To determine the distances to galaxies like NGC, 105 astronomers rely on a sophisticated set of techniques known as the cosmic distance ladder. Each rung on the ladder allows us to measure farther out into the universe, but each depends on the calibration of the rung below it. For the closest stars we use parallax, the same geometric principle your brain uses for depth perception. By observing a star's apparent shift in position against a distant background as the Earth orbits the Sun, we can triangulate its distance. For galaxies farther out, like Andromeda, we rely on those crucial Cepheid variable stars, the standard candles discovered by Hubble. To probe even deeper into the cosmos, we need even brighter beacons. Astronomers use a particular type of stellar explosion, a type Ia supernova. These cataclysms occur when a white dwarf star in a binary system accumulates too much mass from its companion and detonates in a thermonuclear explosion of astonishing and, more importantly, predictable brightness. For a few weeks, a single supernova can outshine its entire host galaxy. By spotting these explosions and measuring their apparent faintness, we can calculate the distance to galaxies billions of light-years away. Finally, for the most remote objects in the universe, we rely on redshift. By measuring how much the expanding fabric of space-time has stretched the light from a distant galaxy, we can infer its distance. It is this ladder of knowledge built over a century of brilliant and tireless work that allows us to add depth to the flat tapestry of the sky. It is what empowers us to see NGC 105 not as a site of collision, but as a foreground object against a far more distant backdrop. It allows us to place both galaxies in their proper context within the vast filamentary structure of the universe known as the cosmic web. On the largest scales, galaxies are not distributed randomly. They are arranged in a stupendous network of massive superclusters and long thread-like filaments of galaxies surrounding immense, nearly empty regions called cosmic voids. NGC 105 is just one member of this web, a single node in a network of unimaginable scale floating in the Pisces-Cetus supercluster complex. The smaller background galaxy is part of an entirely different, more distant thread in this same cosmic tapestry. Their apparent proximity is a cosmic coincidence, a momentary alignment in a universe of endless possibilities. Now, with the illusion stripped away, we are free to see NGC 105 for what it truly is. It is a magnificent spiral galaxy, classified by astronomers as a type SAR. This designation comes from Edwin Hubble's own classification system, often visualized as a tuning fork. On one side are the smooth, featureless elliptical galaxies. On the other are the spiral galaxies, which are subdivided based on their appearance. Type SAR galaxies like NGC 105 are characterized by their large, bright central bulges and their tightly wound, almost indistinct spiral arms. This structure suggests a galaxy that is mature, its most frantic era of star formation perhaps already in its past. The prominent central bulge is dominated by older, yellower and redder stars which have been orbiting the galactic core for billions of years. The more subdued spiral arms are where the younger, hotter and bluer stars reside, along with the lingering clouds of gas and dust from which new generations of stars will eventually be born. It is a portrait of majestic, quiet elegance, a self-contained stellar metropolis pursuing its long, solitary journey through the void. Located in the constellation Pisces, the Fishes, it is one of countless such islands of light scattered across our sky. From a distance of 215 million light-years, the light we are capturing from it tonight began its journey to Earth during the Triassic period, when the first dinosaurs were just beginning to walk our planet. For all that time, those photons have traveled unimpeded across the expanding universe, only to arrive at our telescopes in the same patch of sky as photons from another far more distant galaxy that began their own journey over 500 million years ago. The two streams of ancient light have converged here now at our location to paint their false and fleeting picture. This story of NGC 105 is more than just a clever piece of scientific detective work. It serves as a profound metaphor for the very nature of scientific inquiry. The universe does not readily give up its secrets. It presents us with phenomena that are often misleading data that can be interpreted in multiple ways. Our first impressions, guided by intuition and pattern recognition, can be powerful, but they can also be profoundly wrong. The image of NGC 105 is a siren's song luring us towards a dramatic and exciting but incorrect conclusion. Science provides us with the tools to resist that song. It demands that we move beyond the superficial image and gather more evidence. It asks us to break the light apart with a spectrograph, to measure the subtle shifts in wavelength, to apply the laws of physics, and to build a more complete, more accurate model of reality. The process is one of peeling back layers of appearance to get at a deeper truth. In the end, the truth of NGC 105 is perhaps more poignant than the illusion of a collision. The initial image suggests connection, interaction, and transformation. The reality is a portrait of immense, almost incomprehensible isolation. We see a galaxy of staggering beauty and complexity floating in the dark. It is not locked in a gravitational struggle. It is alone. Its apparent companion is a ghost, a phantom from a deeper and more distant past, its image simply passing through our field of view on its way to somewhere else. This cosmic illusion reminds us that we are not just passive observers of the universe. We are interpreters of it. We inhabit a single privileged viewpoint in an ocean of space-time. From our tiny perch, we piece together the cosmic story one clue at a time. Every image from a telescope, every line in a spectrum, is a piece of a puzzle of infinite complexity. Sometimes, as with NGC 105, a puzzle piece seems to fit perfectly, only for a new piece of information to reveal that we were trying to connect two entirely different sections of the puzzle. But there is no failure in this. Every illusion unmasked, every hypothesis discarded in the face of new evidence represents progress. It refines our understanding and sharpens our tools for the next mystery that the cosmos presents. So let us look again at this stunning vista. Let us not see it as a collision that isn't happening. Let us see it for what it is, a testament to the sheer scale and randomness of the cosmos. A universe so vast and so full of wonders that just by chance, two magnificent galaxies separated by 400 million light-years of emptiness, can align themselves perfectly to create a moment of fleeting, illusory drama for observers on a distant world. It is a reminder that the universe is not required to be simple or to conform to our expectations. Its capacity for generating beauty, complexity, and even deception is boundless. Our journey is to learn its language, to decipher its codes, and to slowly, patiently build a true picture of its magnificent reality, even when that reality is hidden behind the most convincing of cosmic illusion. The truth is always out there waiting, not just to be seen, but to be measured.
Yet deceptive image of NGC 105.